Hi, so today I want to share with you something that I would call cosmic eye candy. Simulations and illustrations of some of the amazing processes that are going on in our universe right now. And we start with the scale of our universe, zooming out from one galaxy that's about few 100,000 light years across. Further away until we begin to see tens of galaxies. Hundreds of galaxies. Thousands of galaxies and galaxy clusters, and all of these galaxy clusters form something that we call the cosmic web. This is the cosmic web. Now this is one of the most incredible simulations, I think. This is the simulation of the cosmic web itself. This is hundreds of millions and billions of light years across, showing this kind of web-like nature of the cosmic interaction of galaxies and galaxy clusters. Each one of these dense points, like nodes in this network, are galaxy clusters with hundreds and thousands of galaxies in them, interacting in this beautiful, bizarre, wonderful dance. So one of the amazing objects in our universe are stars. Stars are responsible for all the life and interesting things that we see around us. And the death of big stars is responsible for pretty much all our technology and all of our life. Because it's this enormous explosion of gigantic stars that creates all the heavier, interesting elements that we need for life and our technology. So these are some really interesting looking simulations of stars going supernova. So this is all going on at incredibly tiny small timescales, fractions of a second, and what they show is sort of turbulence and chaos that's going on in the core of the star. Because what a supernova is, the star is balanced by the two forces from the explosions going on from the inside in the nuclear fusion that's pressing outside, and the gravity of the star trying to press inward. The star is a result of the balance between these two forces, and if one of these fails, if the stars run out of fuel in their cores, then this process begins to happen if the star is massive enough. There is no pressure coming from inside of the star anymore, so all of the mass of the star just starts collapsing inward at significant portions of the speed of light. So with stars that are massive enough, stars that are about few times more massive than the size of our own sun is about 300 times as massive as planet Earth. So if you have a huge star and it goes through this process of a supernova explosion, then at one point of the star being massive enough, there is no force of nature that can keep it from collapsing into a singularity, an entity that we call a black hole. A black hole is a region of space-time that has such high gravitational pull that absolutely nothing can escape it, not even light. So this is one simulation of what a black hole would look like. This thing around it that you see, this is called the accretion disk. And this interesting effect that you can see what's happening behind it. This is due to the black hole being so powerful in its gravity that it can also bend light around it. So you're literally able to see what's happening behind the black hole. This is just one of the profoundly strange properties of black holes. Where the black sphere in the middle begins, that is called the event horizon. That is the point through if anything passes, it can no longer return to the outside universe. This is a really cool simulation of black holes colliding. A simulation trying to see what it actually would look like. So these black holes colliding are one of the most powerful events in our universe. And they release tremendous, incomprehensible amounts of energy. And here you can see the beautiful light distorting effects that they have also taken into account in the simulation. So it's pretty much impossible to truly get across how powerful these objects are. And once these black holes get really close together, they can spin around each other tens and hundreds of times per second. So these are just some cool illustrations that I wanted to show you. Fascinating stuff and beautiful to look at what computational power we have to simulate such powerful events in the universe. So I hope it was interesting to look at. If you have any thoughts, please share them in the comments. And of course, thank you so much for watching and take care.